Neural network explained using 25 topics. A neural network is a type of computer system designed to work like the human brain. It processes information by connecting many small units called neurons in layers. These neurons work together to recognize patterns, make decisions, or predict outcomes based on data. Neural networks are used in tasks like recognizing images, understanding speech, and making recommendations. Here are 25 topics that will help you understand the concept of neural network. 1. Neurons in the brain. A neural network is inspired by the human brain, where neurons connect and communicate to process information. 2. Artificial neurons. These are computer versions of brain cells, called nodes, that process and pass information. 3. Inputs. Data enters a neural network through input nodes, like how we perceive things through senses. 4. Weights. Each input has a weight, which determines its importance in the decision-making process. 5. Summation. The inputs are multiplied by their weights and summed up in a neuron. 6. Activation function. A mathematical function decides whether the neuron gets activated, passes information forward. 7. Layers. Neurons are organized in layers, with the input layer taking data, hidden layers processing it, and the output layer giving results. 8. Connections. Neurons in one layer connect to neurons in the next, passing information through the network. 9. Forward propagation. Information flows from the input layer to the output layer during prediction. 10. Training. Neural networks learn by adjusting weights and biases to reduce errors in their predictions. 11. Supervised learning. In this method, the network is trained using labeled examples, input-output pairs. 12. Error. The difference between the network's prediction and the actual result is called the error. 13. Backpropagation. This is the process of sending the error backward through the network to adjust weights and improve learning. 14. Learning rate. A small value that determines how much weight should change during training. 15. Epochs. One full pass of the entire training data through the network during learning. 16. Overfitting. When a neural network becomes too good at memorizing training data but performs poorly on new data. 17. Underfitting. When the network is too simple to capture patterns in the data. 18. Activation functions examples. Common ones include ReLU, rectified linear unit, sigmoid, and TAN, which control how signals flow in the network. 19. Neural network types. Different types include feed-forward, convolutional, recurrent, and transformer networks, each suited for specific tasks. 20. Convolutional neural networks, CNN specialized for analyzing images by detecting patterns like edges and shapes. 21. Recurrent neural networks, RNNs designed to process sequences of data, like time series or text. 22. Deep learning. Neural networks with many hidden layers are called deep neural networks, used for complex tasks like self-driving cars. 23. Data preprocessing. Before training, data is cleaned and normalized to ensure the network can learn effectively. 24. Testing and validation. After training, the network is tested on unseen data to evaluate its accuracy. 25. Applications. Neural networks are used in tasks like image recognition, language translation, medical diagnosis, and game playing. These topics provide a comprehensive view of how neural networks work, how they are trained, and their various applications.